Hello, everybody. Happy Tuesday. So, taking a look on the right hand side, you guys are going to be needing your workbooks today, and you're going to be using them along with this video to go through our lesson today. Then you're going to follow that with a Google form, and the link is in this presentation. And finally, you need to complete 15 minutes of iReady. You need 60 minutes for the week. So, again, you can complete all 60 minutes in a day. Just by the end of Friday, you need to have 60 minutes. So, our math standard, again, is still the same. We're looking at attributes of two-dimensional shapes, and we're looking at how we can group them within categories and subcategories. That term subcategory came up on Friday, and a lot of us struggled on our exit ticket. So you can see that for today, we're going to start by reviewing the subcategories on that exit ticket, and then we're going to continue to develop those concepts. So before we get into looking at that exit ticket, I want you to take a look at these vocabulary words. We know that an attribute is a trait, a characteristic of a shape. And when we're talking about attributes, we're really looking at number of sides, equal sides, the angle lengths, parallel sides, perpendicular sides, things like that. And then you can see a category is just grouping things together based on an attribute. And then a subcategory is another category within that larger category. So a category is generally broad. It talks about a general idea, and then subcategories get more specific. We took a look at Venn diagrams last week, and we also took a look at tree diagrams. A Venn diagram is when you're working with those ovals, and sometimes those ovals overlap, or you can have ovals inside ovals. Or a tree diagram is kind of like a family tree, if you've seen one of those before, but you start at the top and you get more specific as you go down. So this was the example that I showed you in the video last week. You can see most general at the top, mammals. And then as I go down, I get a subcategory of cows. And then more specific, I get another subcategory of a breed of cow. This over here, the one with triangles, actually was the tree diagram to go along with the Venn diagram that was your exit ticket. So don't forget, guys, you can go back into these videos, look in your workbooks as well to help you with your exit tickets. They are open book, open note, open video. So go and use your resources. Again, the broad category would be triangle. Our first subcategory would be isosceles triangles. Why? Because an isosceles has to have at least two equal sides. A more specific isosceles triangle would be an equilateral triangle because that has to have three equal sides. So again, all equilateral triangles are considered isosceles because they do have at least two equal sides, and all equilaterals are considered triangles because a triangle is a three-sided shape with three angles as well. All right. If you haven't grabbed your workbook yet, please push pause on the video and go grab it. If you do have it out already, we're going to flip to page 576, and we're going to go over that exit ticket from the Google form on Friday. A lot of you really flip-flopped where the terms went on all of the questions. So we're going to take a look and break down your thinking a little bit here before we get into today's lesson. All right, so on page 576, looking at question 5, really important to understand the definition of these two here. So equilateral triangles means all sides are congruent, and an isosceles triangle means that at least two sides are the same. So use what you know about those triangles to create this Venn diagram. So you can see that I have this larger oval, and then I'm going to have an oval inside of it. So we have to think, are all equilaterals isosceles, or are all isosceles equilateral? Which one's more broad? Well, when I look at this picture of this isosceles triangle here, can I call it an equilateral? I can't, because that base is shorter than the sides. So the broader category would be the two sides that are the same. So on that top line, it should say isosceles triangle, because anything in that circle, this broad circle, can be considered an isosceles triangle. So this one can go over here. This one can also go over here. But with anisosceles, I can get even more specific and all equilateral triangles because they need 3 equal sides. So that's how this Venn diagram matches that tree that we saw before. And I'll flip back to that really quickly. Triangles, isosceles, equilateral. Again, broad, most specific at the bottom. And then looking here, again, you can see the broader it is, it's going to be in the larger circle. All equilaterals are isosceles, but not all isosceles would fit in this here. So use your Venn diagram to complete these statements. Blank is a subcategory, and you can see that equilateral triangles are a subcategory of isosceles triangles. So again, this was our first day looking at it, so I get that it's going to be confusing. It was a develop lesson. So just try and grow your thinking as we go through. Also, jot down any questions you have and shoot me emails throughout the day, and I can give you that feedback right away. All right, so we're now going to flip to page 578. So go ahead and do that now. All right, so here we have 2 more shapes that we're looking at, and we want to write 3 attributes shared by all rhombuses and 3 attributes shared by all squares. So this one here that looks like a little slanted, that's your rhombus. And this one over here is your square. So I kind of gave you a clue of what you're going to be writing in your workbook. So the first thing I want you to do is make an observation about the number of sides. And I want you to fill it in for rhombuses and for squares. Next, I want you to make an observation about parallel sides. Remember, parallel means that they will never ever touch. So 2 lines are parallel. If they extend on forever and always, they will never touch. For example, if you look at this left side of this blue rectangle and this right side, if these lines were to go on and on forever off your computer screen, up and down, they will never intersect, and that's what makes them parallel. And finally, I want you to take a look at the angles. And then what attribute do all squares have that not all rhombuses have? So this is kind of expecting you to come into this now with some knowledge about what squares and rhombuses are. And it's okay if you don't have that much right now, but just take a look at these 2 images and see what you can fill in your workbook. So go ahead, push pause on the video, answer question 3, and answer question 4 in your workbook. And when you're done, come back and push play. All right, so I hope that you had enough time to really take a look at these pictures. Don't rush, get your ideas jotted down. So the first thing we're going to make an observation about is the number of sides. Well, I can see that both of these shapes look very similar to each other, and they have the same amount of sides. They both have 4 sides, but what's really important about a rhombus and a square is, do you see this? Equal length. It's not that they just have 4 sides, they all have 4 sides of equal length. And you know that because of these tick marks here. So you can see the top, the bottom, the left, and the right in the rhombus are all equal. Top, bottom, left, right of the square are all equal. So again, in order to be called a rhombus, in order to be called a square, you need to have 4 equal sides. So now let's take a look. What observations did you make about the parallel sides? Well, you should have realized that both of these have 2 pairs or 2 sets of parallel sides. The top will never touch the bottom. The left and the right will never touch, and that's the same thing on the square. And you discovered that the other day when we looked at squares. The top and the bottom and the left and the right will never touch each other. So now we're going to talk about angles. So I noticed that a square has that benchmark angle in it, and this one here I don't see any of those right angles. So let's take a look. A rhombus just needs to have 4 angles. Remember, if it has 4 sides, it has 4 angles. If it has 3 sides, it has 3 angles. So in order to be a rhombus, it really just needs to be a 4-sided figure with 4 angles, has 2 sets of parallel sides, and all the sides have to be equal. A square is a more specific or a subcategory of a rhombus because the angles have to be right angles. That's really important. So, again, what attributes do all squares have that not all rhombuses have? Well, all squares, in order to be a square, you have to have a square angle. They have 4 right angles. So a rhombus can never be excuse me, not all rhombuses are squares, but all squares are called a rhombus. Because in order to be a rhombus, remember, 4 equal sides and 2 sets of parallel sides. But I can't call this a square because of its angles, and that's what sets a square apart. All right, so I want to draw your attention to this quadrilateral cheat sheet down here at the bottom. So we talked about rectangles last week, as well as we talked about squares, and today we threw a rhombus into the mix. So you can see that all of them have 2 sets of parallel sides. All right. This one here says 4 sides of equal length, 4 sides of equal length, 4 right angles, 4 right angles. So again, you can start to see the difference here. So I want you to try and do 5 and 6 on your own. So which of these statements is true? And I kind of already talked about it on the previous slide. And then again, are rhombuses a subcategory of squares or squares a subcategory of rhombuses? So I did address 5 and 6 on the previous slide. So push pause, answer these 2, come back and we'll talk about it. All right, so which is which? Is every rhombus a square? So is this rhombus? Can I take this picture and put it in this category? I can't, because in order to be a square, it has to have 4 right angles. So every square, though, is a rhombus because I can take this picture of a square, put it right here, and it would have 2 sets of parallel sides and 4 sides of equal length. So that means that squares are a subcategory of rhombuses. So again, at this time, if you're feeling confused, you need to shoot me an email so I can address this with you today. But now we're going to keep going. So taking a look here, this is the start of the next lesson. So it talks about a hierarchy. A hierarchy orders categories from most general to most specific. In this Venn diagram, list attributes for 4 categories of quadrilaterals. Use the terms below to fill in the names of the subcategories from most general to most specific. So we're going to take a look at this together. All right, so you can see here that I did include the definition of parallelograms, rhombus, rectangle, square, and we know that the top one they filled in for us right here, you can see that it says a 4-sided figure is a quadrilateral. So this outer circle is the most broad, okay? And we're going to work our way in. And because the smaller circle is the most specific, and this smaller circle can meet all the other qualifications. All right, 2 pairs of parallel sides. Well, anything that has 4 sides and 2 sets of parallel sides is called a parallelogram. So again, you see that word parallel in it. So a parallelogram is any shape whose top and bottom won't touch and left and right won't touch. All right, so now I need to find something that's considered a parallelogram and has 4 right angles. So you can see that, well, wait a second, a rectangle says 2 pairs of parallel sides. That's what a parallelogram is, as well as 4 right angles. So there's your rectangle. A rectangle is considered a parallelogram, which is also considered a quadrilateral. A rectangle is a parallelogram. A rectangle is a quadrilateral. And finally, something that is a 4-sided figure, something that has two sets of parallel sides that has four right angles, but also has four sides of equal length. So when I look at those choices, you can see, well, wait a second, a square has the two parallel sides, has the four right angles, and has the four equal sides. So you guys might have done something like this in science or maybe social studies. You can kind of think of this if you think of the world on the globe. So we all live on the earth. And then we get more specific. We live in North America. We live in the United States of America. Let's get more specific. You can see how our circles are shrinking and shrinking. We live in the state of New Jersey. We live in Franklin Township. Within Franklin Township, maybe you live in Franklinville. And then you can get even more specific. You have your street that you live on. So that's kind of what's happening here as we classify and sort our shapes. This square is all the other circles around the outside of it. All right. So this is number 2 here, and you can see that it says use the Venn diagram and what you know about quadrilaterals to complete the table. Fill in the subcategories. So I do want you to push pause on the video and go ahead and fill these in so you have this example in your book. You can see that, again, anything that's a quadrilateral is a four-sided figure. Our first subcategory is a parallelogram because it has two sets of parallel sides. And again, you see parallel in the word. A subcategory of parallelograms is rectangles. Now you can see that it has the four sides just like the two things above it. It has the two pairs of parallel sides like the parallelogram. The additional information is that it has to have four right angles. Finally, our last most specific subcategory, because remember, as you go down this list, they get more specific. They have more rules they follow, is a square. And again, a square is going to have all of these other things up here. You can see it's a four-sided figure, like a quadrilateral, two pairs of parallel sides, like a parallelogram, four right angles, which makes it a rectangle, and also four equal sides. So again, broad, and then a square is a rectangle, a square is a parallelogram, a square is a quadrilateral. A rectangle is called a parallelogram. A rectangle is called a quadrilateral. A parallelogram is called a quadrilateral. So looking at how specific it goes. All right, so taking that exact same thing that we were just looking at, here it is now in a tree diagram. So back here is your quadrilateral cheat sheet, and we're going to continue to use this information to build connections between these shapes. But again, we know that quadrilaterals was the most broad, four-sided figures. Now, which of these parallelograms, squares, or rectangles would come next? If you remember, we talked about just needing to have two sets of parallel sides. So a parallelogram is our first subcategory. More specific, two sets of parallel sides as well as four right angles. Next is going to come rectangle. And finally, the most specific shape we can have out of this list is a square, because a square is a rectangle but also has to have four equal sides. Go ahead and make sure you have this information down in your workbook under number 3, and you can see that connection between what we have here as well as what we have here. You can see quadrilateral starts at the top, squares end at the bottom, as well as here with our tree diagram. All right, so that concludes our lesson for today. Again, you can see that we continue to build on the relationships within these shapes, looking at the subcategories and how squares are rhombuses, squares are rectangles, and squares are parallelograms. And you can use this chart to help you. In your exit ticket today that you'll find on the next slide, I did include this chart to help you. So make sure that you use it and read the statements carefully. If you have any questions, please make sure to shoot me an email. And then if you need to go back and watch this video, have it open, use it. Use your workbook while you're taking your exit ticket. This is your resource. And then the last thing that you'll have to do is make sure that you complete your iReady path. Now, yesterday I did assign an iReady lesson. If you didn't do that, you might want to take care of that before you take your Google form because it was a lot of information on classifying shapes. All right, guys, I hope you have a great Tuesday. Please make sure you reach out and, just even if you just let me know how you're doing, if you want to chat about non-math stuff, shoot me an email, okay? All right, have a good time with the lesson, and I will see you tomorrow.